Hello and welcome back to Talking Transformation, the Appledore Research Podcast. My name is Robert Curran, Consulting Analyst with Appledore. There's no doubting that Agentic AI is capturing the imagination of pretty much everybody involved in automating the operations of telecom networks. It's a hugely exciting prospect. The idea that software agents are going to relieve workload of frontline teams in identifying, diagnosing, resolving network issues autonomously. Really great idea. However, from our recent research, examples thus far seem largely constrained to narrow domains with pretty well-bounded problems and well-behaved data. It's good progress, it's somewhere to start, but where things get more challenging is in these sorts of everyday issues that involve more complex networks and services where deeper understanding is necessary, not just more data. Exactly how telcos can bridge to this next level of sophistication is our topic of conversation today. I'm very pleased to be joined by a true pioneer and veteran of the networking business. He's Dr. Dale Skeen. He's the CTO at Vitria Technologies. Dale has a PhD in computer science from the University of California at Berkeley. He co-founded TIBCO, legendary company, and he's been an assistant professor at Cornell University. He also just happens to have numerous patents in networking. In 1994, he co-founded Vitria with Dr. Jo Mei Chang, and in the last 3 decades, Vitria has been building deep expertise in telecom domain knowledge, network operations, and the whole business of automation. In fact, Vitria's VIA AI Ops platform is deployed in some of the world's largest global networks, delivering measurable reductions in incident volume, mean time to repair, improved service availability, and accelerated time to value. Hi, Dale, and welcome to Talking Transformation.
Well, it's a pleasure to be with you today, Robert, talking about some of my favorite topics, and I thank the audience also for joining.
Excellent. Dale, it was good to see you at FutureNet in London last week. That was quite a sizable event, noisy, and thank you for bringing over Californian weather. I think for those who have been to London more than once, they know it was unseasonably warm and pleasant. The FutureNet audience has grown over the years, and I think that indicates the strength of interest in automation and in AI. Is that what you're seeing reflected in your conversations with your telco customers? And what are they seeing as challenges as they try to increase the levels of automation?
Yeah, well, certainly we're seeing that with our customers and with the market at large. People get into the conversation of how can they use AI, how can they use Agentic AI. And as you mentioned, most of our customers tend to be top-tier telcos and ISPs, having a variety, a mix of networks, legacy and new networks, 5G, cable, legacy networks. So it's a real mix, but they're really struggling to bring, I think, Agentic AI to help with our problems. And by the way, I should mention that for our customers, we provide them observability, AI ops, and automation. Okay. And so, working with customers, especially in trying to install this functionality, we realized that they were having limited success with their Agentic AI, as you pointed out. It works for sort of smaller deployments, simpler tasks, but when you try to scale it up to more complex tasks and decision-making, then we see limits in accuracy and hence trust. These become very real limiting factors. So a few years ago, we started researching how can we get around those barriers. And so we started pioneering the use of knowledge to address these limitations that we were seeing, okay? And so over the past few years, we have bundled knowledge capabilities up into something we call a semantic knowledge plane that serves as a layer above our AIOps tool sets, okay, to sort of, if you will, infuse the AIs with better knowledge, leading to better accuracy and better results.
Interesting. We're right in the meat of it here. This transition from data into knowledge and your experience with your customers. Something I know that listeners might be aware of is the concept of a knowledge graph. Can you distinguish between the sort of semantic knowledge plane that you've mentioned and kind of knowledge graph technology? Are these one and the same thing, or how do they differ?
No, they're different. Let's break it down by component. You already mentioned knowledge graph, which I assume that most listeners are familiar with. Knowledge graphs as represented in something like RDF format. They're both machine and human readable. They've been around for quite a while. Okay. Now, let's focus on the word semantics for a moment. Okay. The true power of the knowledge graph is not that it can relate data together, but that you can layer in semantics on top of the data, something a database cannot do. In contrast, think about it. A database, you can know that device A is connected to device B, but what is the nature of that connection? What's the nature of that relationship? You're not going to get that from a database. With semantic knowledge, though, with using a knowledge graph and the tools therein, you can specify those type of relationships down to a fine level of semantics. So, for example, if those two devices you were trying to hook together, one was a Kubernetes pod and one was a host computer, okay, we know that is, or you can add to the knowledge graph, that's a containment relationship with total dependency. So if the host fails, then the pod's going to fail, okay? Whereas if those two devices are routers and that link between them is a partial dependency. One may fail, it will impair the other, or the link may fail, it will impair both, but they won't stop working. So to really get to the level of automation or the level of accuracy you need for automation, you need to be able to distinguish these type of relationships and the semantics of them. Okay. So this also illustrates why data alone is not sufficient. You need knowledge. Okay. But if I may continue, if you think about it, well, then what does plain mean? What's the semantic knowledge? We sort of explained that. What does the plain mean? Well, semantic knowledge plain is a layer that contains the semantic knowledge and a set of tools that allow you to access, maintain, discover, and reason over knowledge. Okay. It supports the implementation of data from multiple existing database sources and systems like network inventory systems, and to fuse that together, okay? And also perhaps to learn relationships between those isolated data sources that you can do now that you bring it together in a knowledge graph. Okay? You can also mine data from other sources like telemetry data. You may find knowledge there. You may find knowledge in like you're importing troubleshooting guides. You may have an LLM parse it, identify the elements of that's in there, and then you can put that into a knowledge, okay? And you may capture knowledge from other sources of truth, either in mining chats that are between your experts to see, this institutional knowledge they have in their heads, but it's not written down anywhere. Maybe that becomes a source that you can add to the knowledge graph. Mm. And the good thing is all of this is cumulative, it's additive. You can, for all these sources, you can add together, so even though the addition of that knowledge is cumulative, the benefit is multiplicative because now you can do cross correlation between all of those knowledge elements.
I think operators are getting to a point where they know they've got a lot of data. I think what you're describing there about knowledge is something they're becoming more aware of, especially as you've indicated the ways in which knowledge is very distributed throughout the organization and different systems. What's the right approach in trying to build a knowledge plane? And it sounds like the kind of thing that operators might try to do for themselves, but what kind of issues have you seen, or what kind of mistakes have you seen companies make in trying to assemble? Because it's very different information. It's very different type of information than just raw data.
Yeah. In these type, building this, well, first of all, you'll need some tooling for this. So I don't think the operators want to build all these tools that I've just mentioned before. So you want to find a source that you can have some of the tooling that you need to build the knowledge graphs, okay? But when they take this on to a project, what we find is actually two issues typically. One is sort of scoping too small. Make a lab experiment under ideal conditions, perfect data perhaps. Okay. And then just because of the size and scope, they're not going to scale up very well in the wild where you have imperfect data and you have missing data, et cetera. So you need more realistic assumptions, okay? And then there's the other extreme, scoping it too large, taking on a complete domain, like the transport domain, and say, we're going to model that, we're going to put all the data we have into a knowledge graph, and then we're going to either tie it to existing functionality, integrate with existing functionality, or bring some new functionality to that. Something that large is going to take years to accomplish, and it's just too long. And by the time you don't get to learn as you go, because you're not really testing it out, you're building this huge project. And so what we find that a better approach is a methodology we call incremental transformation. Okay. And so what we say is choose a domain, but don't try to knowledgeify the entire domain. Instead, choose some use cases, preferably with measurable ROIs, because that may be important to decision makers, as far as finding next steps. Okay. And that's also a proof of value, that what you're doing has value. So, properly scope it so that it can be deployable. And we like to do things in 90 to 100-day chunks, sprints as we call them. Okay. And then you start building out what we call the minimum viable knowledge graph, bring in the knowledge that you need to solve that problem. Don't be too ambitious here, especially in your first few projects. Narrow this time to solve the problem, deploy, verify, and then you may learn and correct a little bit, and then take on the next project, okay? And so you repeat this, okay? And it's an iterative process, and it works because, as I mentioned before, knowledge is cumulative. So you can just add it in, and when you add it in, you not only have new relationships, but you just, based on the data you added in, but you'll discover new relationships between the data you added in and what's there, and that's part of that process. So you're building up this knowledge. Okay, with that. And we find that this is where and when customers are most successful. Okay. And so, while each step in the journey is incremental, the overall journey is transformative. You really transform what you're doing.
Yeah, I can see that's likely to be very appealing to operators. We've been talking throughout our research about the difficulties of transformation, and so certainly in a big bang type context. So things that offer incremental approaches definitely to be desired.
Yes, it is. And this can be applied to a brownfield site or a greenfield environment. And sometimes brownfields serve easier because you already have a lot of the functionality you need. What's missing is knowledge, and you can sort of layer that in on top. So anyway, it doesn't have to be a greenfield new environment that you start with. Brownfield environments are often the places we start with.
Great. Could you share just to make it concrete, some examples of where the semantic knowledge plane has really addressed a critical issue for an operator?
Yeah, well, we focus a lot on in customers' operations centers. We focus a lot on what we call root cause analysis, correlation and root cause analysis. And so because those are functions that are critical to making the right recommendation, getting the right problem fixed, not fixing too many or too few or the wrong issue. And so we've seen where we were able to add knowledge to that we were able to 95% of the time for one customer, they were to detect and triage problems before customer impact. They could do it faster. The knowledge allowed the AI to either recommend or sometimes completely automate the solution quickly. Okay? And so that was a dramatic change for them. We've also seen 20 to 30% improvement in productivity in the NOC year over year. It's consistent when you start putting this in, through, again, these knowledge augmented root cause analysis, likely fix, and automation. Okay, and that is something we've had one customer on journey for more than 5 years, and they've seen that consistently. Other things is, you can reduce the mean time to repair for really hard to resolve service degradations. These are ones that confound the group. You may bring 20 experts together. And so in this case, we find that knowledge augmented insights can dramatically reduce the time those teams and reduce the size of those teams as well, in solving those hard problems.
Yep.
And sometimes you find you tackle problems that teams do very poorly. One thing is correlation across multiple domains, because typically the systems are siloed. Even the monitoring systems and observability systems are siloed. So, for example, you take a 5G network. If a customer is having problems in the radio network, dropping calls, etc., and that problem is caused by a virtualized router that's running a data center somewhere, then you have to do that correlation across 3 domains, the radio network, the transport network that take those signals back to the data center, and then inside the data center itself, where IT is very different. Okay. And so again, putting knowledge together that allows you to do this cross correlation really can make a tremendous impact on these hard to solve problems.
Great. That core issue of restoring service, identifying issues, restoring service. I mean, that's so much a part of the business of telecom and telecom operations. It's great to hear you've got some real success stories in there. Something I noticed from the FutureNet discussions and the presentations that you were doing there and conversations was really interesting. You were taking the knowledge plane concept really a step further. For most people, just getting to the idea of building that kind of knowledge base is a achievement in itself. But you've extended the idea into the whole idea of how this is maintained over time, and you talked about the concept of I think you call it a self-evolving knowledge plane. Can you explain how that plays out? How does this work as a living, breathing entity, as it were, over time?
Yeah. Well, I think one of your points, that's well made, that people struggle with, okay, if I build up this knowledge, I have to maintain it, because stale knowledge is going to, again, cause problems. And so what we decided to do was craft a set of tools that make the knowledge plane self-maintaining insofar as possible, self-governing, and even to a certain extent, self-learning. So it's learning new knowledge about itself, about the system that is. Okay? And we have a wide variety of tools. I can, just give some examples to illustrate. You look at first harvesting knowledge from your typical sources of data, your databases, your inventory management system, your CDMDBs, et cetera. And those tools are in place, not only to harvest it, but also to refresh it periodically so it stays in sync. Okay? And then we look at building tools for mining more non-traditional sources of data. Like I mentioned about telemetry data, often has embedded within it real-time knowledge of what items are related. Like if it's reporting on one device, it may have other devices, neighbors, as part of that, and other links of knowledge, diagnostics that are coming in there. So you mine for that and you put that into the knowledge plane as well. Okay. And then we've developed tools and continue to develop tools to take some natural language things like guides, troubleshooting guides, and to put that into the knowledge plane. And that is a new source of data for most people because it's diagnostic data. It says, okay, when you see this symptom, and this root cause, and this is the most likely fix for it. And so typically people learn that, but if you can find it in guides, then you can put it in there. And that's the beauty of knowledge. You can represent almost anything in knowledge. And so that's a new type of knowledge that you can manage. And then we also are experimenting with capturing chats and logs, people really doing the work, so we can learn from their experience. But also, which we've already done with some of our customers, is we've tied the current knowledge back to trouble tickets and looked at the closed trouble tickets. And not trouble tickets, it will tell you what was actually repaired and what was actually done, what device it was repaired, compared to what was predicted by the AI and what was a recommended fix for that. And so we've now made this a learning system, a system that can learn from its mistakes. So it's a continuously refreshing and learning system. And so it sets up those virtual cycles of learning and refreshing.
Excellent. Dale, you've mentioned decision making right at the top of our conversation, and I know that there's been quite a lot of sensitivity in telecom about the idea of agents and the whole question of trust. We're never very far away from a conversation about that.
Yeah.
How does the semantic knowledge plane concept help overcome issues around trust and letting agents kind of take control, as it were?
Well, actually, there's several ways it helps. First of all, improved accuracy. With the knowledge graph and its broader context and its better semantics, allows the LLM to reason better if you're using LLM. So any agent, so you can tie it to ML agents as well. You may have to do some conversion from the knowledge format to a format the AI can understand, but to any AI, this can be applied. Okay, so it can improve their accuracy. Now, especially if you're talking about a reasoning tool or you're talking about an LLM, you can also get better reasoning out of it because you can request it or force it to use a knowledge graph as a basis for step-by-step reasoning. So you give it the chain of reasoning, and by going down this chain, it will deliver better results. And this has been, there was an interesting study done by a set of professors, I think at MIT. They took, the current releases of most of the frontier LLMs, ChatGPT, Claude, Gemini, some others, and they asked a set of questions. One set of questions are problems to solve. And one problem was, give me the 83rd Fibonacci number. Now, Fibonacci sequence is probably something that people may have heard of. It occurs a lot in nature and studied a lot. So it should be in their training, at least the concept of Fibonacci. And so it turns out that each one of them reported the incorrect response. None of them got the 83rd Fibonacci number correct because they guessed by looking at patterns or whatever. So, but however, if you tell it to generate the first 83 Fibonacci numbers, it got all 83 correct, including the 83rd number. So that just shows the power of directing it to reason, directing its chain of reason or chain of thought prompting. Okay. So better reasoning. Okay, again, improved accuracy because of better reasoning. And then third is explainability. You can ask the LLM in particular to explain its answer in its chain of reasoning across the knowledge graph. So it exposes the knowledge graph for what it used for reasoning. And then you can have an independent LLM verify that, or a human can look over it and verify that. So that gives you explainability and verifiability. And then finally, you can use the knowledge graph sort of as guardrails, not only for verifying, but you can also say constrain your answer and your reasoning to the knowledge graph. Report where you have made where reasoning does not conform or does not follow the knowledge graph. Okay, and so that restricts it. So what you get is better accuracy, better reasoning, explainability, and verifiability and guardrails.
Great. That's a great, clear explanation. I can see how that fits together and reduces some of the concerns that operators have around transparency and beyond observability into how these systems are working. I think this is what you described in the last 20 minutes or so is really a critical capability. I think for telcos in the context we have enormous pressures on speed and agility and so on. Do you think that looking ahead into the future, will there be an increasing difference between telcos that adopt this kind of idea, this concept, and this kind of platform, and ones that try to stay where they are and manage with, I don't know, more staffing or something else? How will we see that diverge, and what will be the evidence that companies are thinking about these in different ways?
Well, I think that question sort of, you can break it down into two parts. You can say, first, can knowledge create a business advantage? And secondly, is knowledge necessary? And so let's answer those separately. So can knowledge create a business advantage? Well, it's going to enable more accurate automation at a faster rate. Once you start putting this in place, and as we said, you can do it incrementally. So you're not waiting for 3 years, but you're doing it as you go. You're just changing the process in which you're building things. Okay. And so it's going to enable that accuracy, which means you'll be able to automate more and faster. Okay. This will give those companies adopting this a cost advantage, which may translate into a competitive advantage because they'll be able to have more autonomous operations and operate either faster or with fewer people. And then finally, I think it gives them an agility and innovation advantage as well, because it's easier to introduce more new services, I think, if you sort of generate new knowledge as opposed to generating new code. So I think they'll find that they will, or maybe on the existing network, be able to innovate faster and try out new types of services more quickly. Okay, so I think it would definitely give them business advantage. Now, I think the bigger question is knowledge really necessary, maybe in the medium term to longer term, because LLMs are getting better. So improvements in AI make knowledge irrelevant. It's something that you won't need in the future. And this is especially true if you believe that artificial general intelligence is coming along. When AGI arrives, then why do you need knowledge? Well, first of all, we don't know if AGI is arriving, and it's hard to predict, how fast current generations of LMs will improve. Okay, but I would say, regardless, knowledge is a tangible asset that can be shared and represents persistent learning over time. And that, I think, is an advantage that will stay with companies adopting it, regardless of how smart the AIs get. Because if you look at the smartest beings on the planet today, which are still humans, what do? Well, when we study problems, we create knowledge, we compile books of knowledge, we teach knowledge. This is how we teach the next generation. This is how we research with our peers. So I think we've seen that intelligent beings have already proven that knowledge is a great advantage.
Dale, thank you so much for your time today and your insights. It's been really good to have someone such great experience and knowledge about our industry, about telecom and networking and operations. Thank you very much for your time. I hope you've enjoyed our conversation.
Well, I've enjoyed it too, and I appreciate the questions and the dialogue. And by the way, I want to thank the audience. If you made it to the end, then I think you're doing pretty well. Thank you.
That's great. Okay, Dale, thanks very much.